Morning, everybody. Loved the party yesterday? Yeah, of course, with Dylan playing and singing. Yesterday was the first time that I had a chance to listen to Another Brick in the Wall, and especially I loved the lyrics, we don't use source control. Fantastic, wonderful. And thinking of Dylan and his wonderful work, and looking at the title of this presentation that has been in front of my eyes for the past 10 minutes, another title song appeared in my mind. Smoke gets in your eyes, which could be smells gets in your lines of code. I'm not good at singing, even though from time to time, especially at conferences in front of an audience, I try to sing. But I'm not good at all at building, creating music. So this is another idea I will pass on to Dylan for another wonderful piece of song. But anyway, back to our business today, refactoring and code smells. The term smell, whether you take it in English as a verb or as a noun, indicates something you perceive with your nose, that you may like it or not. Now, technically, from the dictionary, the term smell is relatively neutral. So it doesn't mean exactly that it's a bad feeling or is a good feeling. It's just a feeling that something that you perceive with your nose that gives you some feelings that the context will help you to classify either as positive or negative. In software, however, code smell is something that you better not have. So if your code smells, some deodorant would be recommended. A code smell doesn't mean that there is anything necessarily wrong in your code. So a smell, just to keep the metaphor going on, doesn't mean that your code stinks of garlic. But yet, a little bit of analysis on your code is, and then possibly refactoring is recommended. So in this presentation, I'm going to go through a list of popular code smells. I'll stay rather general in listing common, most known code smells, and I will just go through a bunch of general code smells that apply to the code base as a whole, and then I will go into a little bit more details for things that you can possibly do or not do at the class and method level. And then the rest of the presentation, I'll go through 7 gold virtues of, I'm tempted always to say modern software, but let me retain and say just software. So the simple case of special strings, so not using strings, but using anything else that better renders the concept behind, the role behind the use of a string in a segment of the application. Join data that want to go together. Readability, every class begins with a new, so the whole team of factories. Dependency injection, null pointers, and you ain't gonna use it, so when you think too much ahead of your code. A code smell, anyway, in software is not pleasant at all, and at the same time is an odor, not necessarily a good odor, and the question is, should we take care of that? It's not a bug. Don't take it wrong. It's not a bug, but it's something that is there, is not appropriate, is not perfect code, it's not the code you can be proud of, maybe not the code you would showcase to your peers, but it works, and it's not a bug per se. It doesn't take the code to misbehave, the application to produce unexpected results or unpredictable outputs. It's there, it pays its dues, it works as expected, but it's not ideal. So it can be improved. And the question is all about, should we improve it? Should we refactor the code to take that odor? Should we wash the code to take the odor away? The answer is
If the answer has to be yes or no, the answer is yes. But yes means that some more action should be taken. And taking action in the context of a software project means money, means time, means impact on your work and the work of your peers. And the amount of impact that refactoring a code smell may have on your work and the activity of your peers depends on the nature of the code smell. Trying to wrap up the definition of a code smell is something that it is immediately, instinctively perceived as not to be right. There is no need to fix it right away, but it won't improve over time. So it don't get fixed automatically. You have to, at some point, you have to put your hands on it, and the risk is that it will never get any better. It will stay as is, or it will take the down slope and degrade into why not, a bug or a significant issue with your code. And the aspect of the code that is most affected by code smells is maintainability. Even though someone said that any line of code is legacy the second after it is written. So the moment you hit save, that line of code you just written, that fresh line of code is legacy code that at some point need maintenance. So 3 types of code smells: method, class, level, and general. Dead code at the method level is the most popular one or the most common one. Before I started using many years ago on a regular basis tools like ReSharper and CodeRush and similar tools, I never realized that my code actually contained dead code. You write your code, you know. If there is no tool that tells you that, most of the time you just don't realize that there are branches in your methods that never hit. And I was almost offended the first time that ReSharper told me, oh, showed in light gray a few lines of code, methods also in a class. And then when I popped up the tooltip, it says, this code is never reached, this branch is never reached, you can take this code away. What? It's my code, it's not your code. ReSharper, you know, be serious. But yes, that code is there. Now, that code is not dangerous because it's dead, but it stinks. And now, the negative aspect of that code is that if some people in the team is not using a tool that marks that code as dead and guarantees this code can be safely removed, nobody will remove it. So that code is still possibly subject to unit testing. It's in the source control, unless you are like Pink Floyd, and we don't use no source control. So it's there, and because it's there, it plays a role. Better get rid of that. Lazy method. Lazy is lazy. Why having a method that does essentially nothing or very little? Again, why should we remove it? Now, tools like even smart tools, code assisting tools, can hardly tell you, hey, look, this method looks a bit too lazy. You might want to give it a little bit more of energy and maybe mix with some other methods to make a stronger, more energetic method. So lazy methods are, for lazy methods, there is no absolute metrics to identify them, but yet they are dangerous because they proliferate and they make reading and understanding the code, especially for new people on the team, more problematic. Lazy method and God methods on the other opposite, a method that does everything. Now, on methods that do everything, there are a lot of nice stories about developers. And I believe that it all depends on what our professors, university, and professors of professors, dating back to the late 60s, when the concept of software engineering came up, and the similarity between civil engineering, building constructions, and building software seen as the same comparable disciplines, there was the idea that any piece of code should be as flexible as possible. And when I was a younger developer, so some 25 years ago, we felt pure excitement in the team whenever we found out that, oh, we have this method here. Okay, we were using no classes because we were programming in C. So we had, you have this function, it has already 12 parameters, but if we had a 13th parameter, we can make this function callable in 10 more places. God object, God method, crazy. But yet we were excited about that. We felt so smart because we figured out that with 13 methods, our function could do nearly everything. And we were even dreaming of one program, one function. Every function a program. Wow. Middleman, the man in the middle. This has to do a little bit with politics or lobbies. So I'm in the middle, I take here and I pass there. And on the way, okay, I take something out. Just for my being in the middle. But beyond the bribes, corruption, and everything related to the dirty world of public management of countries, in software, middleman takes out maybe performance. It depends, because if the middleman is in the middle of the space, the middle of processes, yeah, it's an issue of performance. Otherwise, it's something that kills readability, understandability of the code, and makes everyone that gets to read the code to say, who's the idiot who wrote this? Didn't they realize that this class or this method in the middle is doing nothing? But at the same time, it depends on what the actual reason why you may have in some areas, small areas of your code, middlemans. For example, if you think of controllers in web applications, then there is the controller, and then there is, at some point, 90% of the time, there will be a class, a repository, that does some database work. So in the middle of these two extremes, the request that hits the server, the controller that takes it, the controller that starts processing, and then the controller figures out what to do, and what to do is reading or writing to a database. Along the way, how many things should happen? Now, not in all actions managed by a controller there will be that many things that would justify a service method, a worker method in the middle. But if I have to suggest a general way of approaching software development, I would say always put a worker method in the middle. It means that sometimes the worker method will just take parameters from controller and pass parameters to the repository. So it would be a perfect example of a middleman, possibly useless method. But it plays a role because, and the role is taking this pattern expanded to the size of an entire code base will teach developers an excellent way of partitioning, layering the code, because there will be other controller methods that trigger actions where there is a bit more logic that would fit perfectly in the middleman populating, making reach of action the worker, the otherwise empty worker method, while preserving the single responsibility principle. The controller does collection of input and triggers the workflow. The worker method organizes the workflow. The repository does only database access. And we have three entities splitting more or less equally the responsibility of taking the action home. Long parameter list. I already mentioned the sad story when I was a young developer. We had a function with 12 methods, and we just added a 13th method because to our eyes, it would make the code look smarter. Long parameter lists are not, honestly, a bad thing per se. They only affect, I would say, readability. You might wonder if the link is long enough. So if the method you are defining with that long list of parameters really needs all of them. So if the method, too many parameters may suggest the method does too many things. So that may suggest that the method with that long list is a sort of a God method. So you can make it a semi-God method and create two semi-God methods instead of just one. But in general, if you have 5 parameters because the method needs 5 parameters, I would suggest you group them together into a helper class that just transports data. An immediate benefit you get out of this is that the moment you need to add a 6th parameter or remove the 5th parameter, so the moment you have the need to change the size of the list, if you have a single class that wraps them up all together, you don't have to change any signature, you don't break any code, okay? You just have to focus your attention on how those parameters are passed and received. So the area, the surface of your code that is impacted by this change is significantly smaller, and more to the point, is extremely focused to the change that you are implementing. Contrived complexity is, again, obvious. Contrived complexity is complexity that is not necessary. So if you can make things in a simple way, why not? This reminds me of an old comics in which there was a guy who, and they are developers, now in the picture they are all developers, and they are eating, and one says to the other, "Can you pass me the salt, please?" And then, wait. "Can you please pass me the salt?" And then he says, "Oh, well, sorry, I'm developing a system that will pass you arbitrary condiments. But it's been 20 minutes, but it will save time in the long run." So this is contrived complexity. If you need to just something that passes the salt back, pass the salt back. I see, okay, in theory, that would be nice to have a system that could generate and pass arbitrary condiments, oil, whatever, pepper. But just pass the salt, and then the moment in which pepper, oil, would be necessary to be passed, you approach the problem, and then you possibly expand the solution. Cyclomatic complexity. This is another aspect where aspect of coding, so the level of nestings, for which I really appreciate the work done by coding assistant tools, because they sometimes suggest that you cut something, you rewrite an if statement, for example, to reduce nesting. Cyclomatic complexity is horrible to read. In spite of the possible impact it could have on readability, maintenance, testing of the code, it's ugly to see and would make reading the code more problematic. Inappropriate intimacy is when details of when a method in the execution of its functions deals too much with the internal details of another method. So when the separation between the inside, the internals of methods are not completely watershed. Feature envy, when a method is calling too many methods, properties of another class. So if there's too much interaction between one method and an instance of another class, it's the sign that your code might be or might not be properly designed. Black sheep, this is interesting. Black sheep is, the black sheep in a large set of white sheeps. Why one is black? Is black means it's different. So the black sheep is the sign that your class has the vast majority of methods that seem to go in a certain direction or seem to be written according to certain patterns, certain conventions, and there is one or just a few that are different. Again, the code works, so everything is happy. But it's a sign that there is room for improvement. Class level. Names are more or less the same because things like lazy object or middleman or God method are applicable to methods as well as to a larger, broader scope like that of a class. Primitive obsession. I think that this is a code smell for a class that makes a particular sense, and I would like to warn you very carefully on that. A primitive type, a string, an integer, a long, a date, rarely match with entities of the real world. Now, you may or may not be a fan of domain-driven design, but one of the fundamental aspects, concrete aspects of domain-driven design is design your software model so that it matches carefully what you can observe in the domain, the business domain for which the software is written. So in a way, the software model should mirror the processes in the real world. And when it comes to that, we realize that there is a clear gap between the entities and the behavior of entities in the real world and how we model those things in software. Nulls is the most patent example. The concept of a null, an empty instance of something, doesn't exist in the real world. But in the real world, we have something, we have concepts that null logically the state of an entity, but still the entity exists. And similarly, a string, so a sequence of characters, which is a good low-level way to represent aspects of the real world. A string as a sequence of character doesn't exist. But even the simplest example of a string, a name technically is a name, is an entity of itself, on its own, with certain rules. A name typically doesn't have numbers, may have spaces, but doesn't have punctuation. So if we try to focus for a second on what a name is, so when we have a class person with a property first name and last name, we usually save a first name and last name as strings. But a string is a possibly very long sequence of characters, but any character can be a string, but a name or family name most of the time have their own domain-specific rules for which using a string is an approximation. So you can approximately use a string to render a name, not to mention more complicated things like a URL or an email address. So when a class uses only primitives, it's a smell. The class works, but it's not so close to the business domain as it should be. Is this a problem? Probably not in the moment you focus and write the class, but is a smell, okay, that is better be removed in a deeper refactoring effort. Tell, don't ask. My wife. Tell me what to do. You want me to take the rubbish out? Okay. Tell me, please, this is the rubbish, take it out. No, I'm on watching TV. What are you doing? Do you have anything better to do? Okay, what's the problem? What are you doing? You see, I have been doing that many things today. Okay, what is the point? For example, you could take, okay, tell me, take the rubbish out. Okay, tell, don't ask. So, when, action, method that indicate actions to take. Indecent exposure and inappropriate intimacy. My wife again. I think that if the day that she will catch me in intimate relationships with another woman, I'm pretty much sure that she would define that kind of thing as a form of inappropriate intimacy. But I would reply that day that if there is some inappropriate intimacy between me and somebody else, it's because that somebody else would have had some form of indecent exposure of features that attract interest. So these two, code smells go together. Okay, we should fight the fact that a class knows too many details of the internal aspects, implementation aspects of another class. But when this happens, it's because there is another class that indecently exposes its internals. So these two things go together, and they apply also in life. So life smells. Speaking of life, refuse the bequest. When a class inherits from another class, a parent class, but inherits too much, and I don't need all this. So when you inherit, you get an inheritance from a parent, a relative, and there is good, so money, and also debts. You don't want debts, okay? You just want the money. In this case, you are refusing part of the things you get for free. In software, is an issue because you have inheritance, but this inheritance focuses on only a small segment of the characteristics of the base class. So you have a design issue there. It may or may not be a dramatic issue to solve, but it's definitely an issue. So if you inherit and you don't need 40, 50% of the things you inherit, that's an issue. An issue that probably is related to speculative generality. The killing habit of developers to go up and up and up and up in the hierarchy, up to deriving everything from atom, object. The object, super entity in .NET and Java, well, it's atom. So from here, Big Bang. From here, everything descends. Temporary field, also related to using only partially all the features, all the tools you have around the class. So whatever is a property, whatever is a public or private member needs to have a role, and especially needs to possibly be useful for the entire lifetime of the class. Temporary field means that there are a part of the public or private interface of the class that is only useful for a short amount of time. Again, not that this is bad per se. It's one of the most lightweight code smells. Just how I seem to have smelled this temporary field. But yet is another aspect to take into account. On a more general note, when we design software, essentially classes, losing intent on what we're doing or failing to communicating by name and by public interface the purpose of the class or the method is, this is dangerous. Naming conventions. Oddball solution, when the same problem is solved, so sorting or extracting segments of strings, is the same problem is solved in different ways. I remember this very well from the only time in my life in which I worked with some Java code, because I was hired to bring a large Java code base to .NET. And then I figured out that I knew nothing about the Java code. I only had a faint idea of the intent, okay, of the entire code base. And at some point, dealing into the details of certain method implementations, I found out that they were just essentially looking for a letter, a character in a string. So they were making an index of kind of thing. But this index of, search for the first occurrence of this substring, was done in at least 3 different ways across the entire code base. The code was working, so no problem. But it was confusing to me. And it took me, because I wanted to do a responsible analysis of the code, to waste hours of my time, paid time, okay, to figure out that there were no weird reasons that I was missing for having the same problem solved in different ways. So even a stupid thing like that can have an impact in terms of cost of understanding, readability, and maintainability. Oddball solution, however, can also bring to a combinatorial explosion of complexity. Because you solve the problem here in a certain way, and let's say that in doing that you use an external dependency, and then the dependency change, and then you have to modify things in a number of places. And what is an easy way to solve, to come out of this issue when you are in such a trouble? You duplicate code. Control-C, Control-V. Rename, and it works. Now, I'm not that bad against duplicated code. But code duplication can be a lifesaver, I would say, at higher architectural level. So if we stop thinking for a moment on classes and we think of things like microservices, so code blocks, the relevance of duplicated code changes completely. Because in a class, so we are in the same process space, duplicating code can be a bad thing. But sometimes, if duplicating some code in a microservice saves traffic, okay, in between multiple instances of microservices, that's a different story. So it could even be a form of optimization. Caching, in a way, is a form of duplicating code. High level of vision of the architecture, but caching is a form of duplicated code, and it's an extremely positive way of doing that. Duplicating code, if it's just having the same algorithm in multiple places, if the algorithm is relevant enough, well, you might want to take it out. But at the same time, if it's 3 lines of code, probably, and 3 lines of code you use everywhere or in many places, refactoring to extract those lines could even be worse than the disease you tend to solve. Solution sprawl, divergent change, and shotgun surgery are related code smells that have to do with the fact that you change something here and you break the code in many other places. Or put the other way, you fix something here and then you have to fix, as a result of that fix, many other parts of your code. When there is a sort of inherent intricacy in the parts, in the neural system that connects your code, that can only be originated but not having fixed most of the smells that I listed so far. Deodorant comments, you realize your code is bad, and you put some deodorant of it. You spend time commenting why the code was written there and what should be the ideal way of writing this that you will implement if only you have time one day. But the story is, you will never have time. No chance. So either you do it right the first time or never, if you refactor now or never. Data clumps are one of my favorite, but I think that I can speak about data clumps more in just a few seconds. So now I have 7 small slides to essentially highlight some of the smells listed already. The simple case of special string. You see some code that represents an email class. An email is a string. So you can realistically, and to some extent even acceptably, express an email address as a plain, stupid string. But an email is not a plain string. An email needs to have some methods. Okay, there is the address, and the email address rendered as a string is arguable as well. Because address there is not just a string. It's a string that has some list of characters, not including blanks, the @ symbol, another list of characters, not including blanks, and also with a limited subset of special punctuation chart, with a dot, and then something that should be .com, .whatever. So whenever we treat an email as a string, we need to have a regex in JavaScript and in server-side code to check that the string passed is a valid email address. And just the fact that we constantly use, and Stack Overflow is full of regular expressions that parse string, is the perfect demonstration, is the proof that we fail when we render an email address in our architecture, in our code design, with a stupid string. A class, it doesn't have to be necessarily like that, helps. And when you have a class, you are accepting the fact that an email is a special type, and because it's a custom type you control, you are welcome to add helper methods that will make your code a lot more readable. There's the sample there, there's the get server. All it does is it takes what follows the @ symbol. But imagine now a line of code where you use this class, email.getServer, and you get a string that is .netfest.com. So email.getServer, it's obvious what it does. It takes the server part of an email address. If you put instead the index of blah, 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 those 3 lines, in every place where you happen to work with the server part of an email address, okay, the code works, but who reads that is confused. And maybe even it can go out through that safely. It wastes time. If you like patterns, there is a pattern that explains this point, and it's called the value object pattern. This one is one of the historical design patterns. Data clump, join data that want to go together. So imagine take a look at the 4 methods, 4 properties in a class: booking ID, room ID, date time, 2 date times, nullable from 2. So we are representing a booking. I want to book a room for a number of days. There's not much to object to having from and to date time objects there. But in the context of the booking section of your code base, to and from dates go together, because the booking has a starting date and an ending date. Those 2 days, they go together. they can be separated. But if you keep them separated, it's a form of indecent exposure of internal details. In the world, the booking has a start and an end. So there is no reason for treating in software those two pieces of information as distinct. They go together. Now you see, oh my God, okay, you realize that I see you right, but now I have to and from dates all over the place in my application. And this is where tools can help you. The screenshot here shows the refactor menu of ReSharper. And I think that Visual Studio may have something similar natively. You highlight, you select the two properties there, and you extract a class automatically out of that. Now, replacement throughout the code base is probably not automatic. But at that point, once you have done this, you have a long list of errors, one after the next. You fix it. It doesn't take that much. And either you do now or never. And this is an example of an improvement over code smells. Okay, it takes time, a little bit of time to do, but it takes out, if done regularly, a lot of complexity, a lot of blur on your code. Readability. All methods in .NET have a toString. All classes have a toString method through which you serialize the state of the object to a string. But .NET, since the C# language, since a long time, also added to extend that aspect, extension methods. With extension methods, you can essentially add custom methods also to classes that you don't manage, that you don't own. Extension methods are there just to make your code more readable. Look there. If the ID of a request for something is greater than 0, it means that I have an existing request, and the UI I'm going to display is for editing the request. Otherwise, if it's 0, it means that it's a new request being created. Now, var edit mode can be set to a Boolean by simply making request.id greater than 0. Or you can take the line that calculates the Boolean into a new method called isInEditMode. The readability of those two things, a different level of readability shines. And it's exactly the same code. Now, if request is your class, you can have isInEditMode right in the source code. But if request is not your class, then you can use extension methods in C# to achieve the same. Fixed values, enums, constant, they help to increase the readability of code. So one is a number, it's a primitive type, primitive obsession. If one is behind a mnemonic constant or part of an enum, it's a completely different story. In terms of readability, constructors are another issue. A constructor is an unnamed method, public method. Now, .NET forces you to have all of your classes endowed with at least one constructor. And if your code doesn't contain any constructor, the default constructor, a default and parameterless constructor, is added by the compiler. But again, in domain-driven design, for example, the constructors are contrasted. Because the point that they make is in the real world, you don't create an instance of an entity without a reason. So new type is an abstraction we create in software, but it's a low-level implementation detail. In the real world, we create a new customer or a record for a new customer, a record for a new booking, for a reason. And usually we do that passing parameters. Create a booking, and the booking has an ID, a people, a date, and so forth. So there is always a method in the real world necessary to create entities. And in software, we have factories, factory methods, to do a much better job than plain constructors. So I invite you to think that constructors may be used in code, but constructors are essentially an implementation detail. I recognize that, in .NET, especially when you deal with entity framework, for example, you must have constructors, otherwise classes won't be serialized and deserialized automatically. So sometimes we have to dirty the purity of classes just to come to a compromise with other parts of the framework we are going to use. But okay, if you have use constructors, but try to be aware, to keep in mind constantly that constructors are an implementation detail and that factories are a much better way to stay close to the real world and to make your software model closer to the real world. Dependency injection. I've never been a fan of IOC frameworks, structure map, inject, all those things. So the reason why I have this slide in this presentation is that I just want to call your attention on the fact that the D in the acronym, the popular acronym SOLID, the D is for the dependency inversion principle. And dependency injection is essentially an implementation of that. So designing your code so that external dependencies can be injected, can be mocked, if you prefer to hear a unit testing familiar term, is much more important than using an IOC framework. Because I've seen many times people using IOC, sticking to IOC frameworks as a trend, as a way to feel themselves cool. Oh, I'm using the top cutting-edge technology. Ninject is the IOC of choice today. Why? The point is not whether you use Ninject, this or that. The problem is that thinking in terms of applying dependency injection IOC frameworks takes you to design and to devise your code in such a way every class has external dependencies, so parts of the software it needs to be aware of, injectable. That makes your code infinitely more testable and easier to debug, and also more obvious to analyze. Null pointers. Checking nulls is boring, but everyone fails on that. Sir Hoare, the inventor of quicksort, the quicksort algorithm, and one of the fathers of the ALGOL programming language, an historical programming language of the 50s and the 60s, called the introduction in ALGOL of the concept of a null my billion-dollar mistake. Today, we have in C# and modern languages like C# and Kotlin, we have nullability be taken seriously. So in C# we have nullability only applicable to value types, wherever in Kotlin any type can be nullable. But now in C# we also have the safe syntax to call on null references. So these are all aspects to mitigate the impact, the negative impact of nulls in our code and in bugs that may result at runtime. But notice that null, the concept of nullness, doesn't refer to any, never, domain-specific state. Even though in any business, In the ubiquitous language of any business, we have concepts that can be assimilated logically to the null state of a software counterpart of an entity. But in the business, those are special values. Back to the value object pattern. So the customer reference that is null is better rendered as a valid instance of a missing customer class. That is a much better way, closer to reality, to represent the real world. And our purpose here in this room and outside of this is just mirroring with software the real world. Thank you very much for your time.
We have 5 minutes for 1 or 2 questions. Who wants to be first?
There's one over there.
Okay, thanks.
Another one in the bottom.
Yeah, hi, thank you.
Hi.
I have one question about one specific code smell you mentioned regarding uniting parameters into classes. I generally also support it. However, you should always remember that when you unite them, and if the method is called from, I don't know, 10 places, and then you add one more property, you might forget about 5 places. However, if you had 5 parameters and added the 6th one, the build would immediately fail.
Okay, yeah, good point. I mean, sure. A code smell is not, so calling long parameter list as a code smell is not necessarily an invitation to never use it or to put a fixed barrier. Beyond 3 is code smell, under 3 is acceptable code. It depends on actually the scenario, and maybe the grouping parameters into a single class is a suggestion you can accept in certain areas for certain classes, for certain methods, but not for all of them. So your point is very good. So if I have a list of parameters and this method is called in many different places, but most of the time, or some of the times, these extra parameters go to a default value, then I can find problematic to express the same semantic with a class in which I need to have multiple constructors, multiple factories on that class to represent the scenario in which some parameters take the default value. So it's arguable, and I would say that if you are just in this situation, and you try to take the solution based on a class, but you have to provide some default values in some scenarios, then a possible solution is having a factory on the class that is used to wrap up parameters with a factory method or a constructor with default values. But that's probably contrived complexity. So, okay, so it depends. As usual, it depends. But good point. There was another question at the bottom there, if someone can...
Yeah, I see.
Hi.
Hey.
What do you think about extension methods for primitive types? For example, strings or integer?
I have on NuGet a package I've done for, and I use it in my implementation, where the string class is the class with the longest list of extension methods. So I personally use a lot of extension methods on the string class regularly, and extension methods are one of my favorite. One I use most is null or a white space. You may tell me that, okay, but is null or white space in .NET is a method you have out of it's a static method, so you have to do string dot is null or white space, and then you pass as a parameter the string. An extension method allows you to take the string and then call is null or white space that calls into the static method. So it's just a way of reverting things, but it increases the readability. Other methods I expect to have on a string class is methods to extract segments, slices of the string, the part in between this and this substring, and essentially operating methods. Also another method is conversion from a string to a number if the string can be converted to a number. For example, if you have the string 1 and you want to have the integer out of that, it takes 3 lines of code in .NET. Integer.parse and then all the error handling around it. Maybe 2 lines with the latest C# with the out var and things like that. But it's at least 2 lines, and those 2 lines never reach the readability of string.toInt, possibly with an optional parameter in the toInt method that takes, if it cannot be converted to a string, assign this default value. So I definitely welcome extension methods also on primitive types as a way to increase significantly the readability. Thank you for the question.
Okay, for your information, Dino will be able in speaker corner, and if you have more questions, you can find him there. And if you could, let's give a round of applause for Dino.
Thank you.
Thanks so much.
By the way, I will host through JetBrains a webinar on these topics with slightly different examples. But if you're interested or you want to tell to your colleagues, that will be next week, Wednesday in the afternoon. But for more information, you can visit the jetbrains.com website. Again, thank you.